I will talk about the regression part after we get the data from the linguistic feature and the acoustic features. I think Srikan and Felipe already talked about how do we get the linguistic features for the neural network training, and also how do we get the acoustic features for the neural network training. So after that, the only problem is how do we do the regression. So actually the regression will be very straightforward, just to map the input data to the output data. So because here we are not focusing on the neural network stuff, we will give a very brief high-level stuff of the neural network and give some examples. How do you train an acoustic model or duration model using the Merlin toolkit. So after we get the input and output features, one very simple, naive way is to train a feed-forward neural network. The input is just the linguistic feature, and the output is the acoustic features. We do it frame by frame. If you want to consider longer context in this architecture, we can stack the linguistic feature from several frames to do that. But you please remember that I think Srikan and Oliver already mentioned the linguistic feature has already spent a longer time. So, but in the feed-forward neural network, we did not consider the contextual information. So one way is to consider the contextual information is to using the recurrent network. In the recurrent network, the output of previous time step or some hidden activation will send to the next time step as the input or passed to some hidden layer to do the regression. So here there is a kind of memory. We can use that memory to remember what's the information in the past or in the left context. Of course, we can use this to remember the information from the past information if we do the bidirectional recurrent. But you know, when we do this very naive way recurrent, it's like we train a very deep network. So this network is usually very hard to optimize. So that's a well-known vanishing gradient problem for the long sequence. So one solution is to this one is we do the IS2017. That's a very known architecture. So in the IS2017, we are still doing recurrent. We pass the state of current time step to the next time step. So with that, we can learn the information from the past time step. Let's take a close look of how the IS2017 cell looks like. There are many lines and circles. Don't worry about that. The most important one is the forget gate here. The input gate and the output gate just to do the scaling of the signal. I think we did one paper last year at ICASP. We found the forget gate is the most important unit in this architecture. So maybe other gates can be removed safely. If you want to learn more detail, you can refer our paper there. So here is what we have learned now. Is in what we have learned in the neural network, we assume the input and the output data have the same length. They are aligned. So they have the same sampling rate. For the feed-forward network, there is no memory. They only take the current input and get the corresponding output. The RN can did something to remember, to model the context. But here, there is one issue is the alignment is coming from one external model. We need one duration model to align the source, not the source, the input and output features. So if the input data and output data has different lengths, what shall we do? One solution is we do the sequence-to-sequence training. For the well-known method is using the encoder-decoder network. So for the encoder, we can encode all the input sequence into one fixed vector. So here is some conceptual diagram for the encoder-decoder. This one block means one network. So for the encoder, we take the sequence of the input data and encode into a fixed dimensional features. For the decoder, it will decode the fixed dimensional vector into a sequence of the output feature. And the decoder also will decide where to stop the output feature generation. But here in this encoder-decoder architecture, there is no alignment within the model training. It's only based on the fixed length vector. So we can put some attention to this model to learn the correlation between the input and the output is a kind of alignment. So we can do that better. For example, one output, it can have access to all the input vector, also can access to the past output. Because today we are not going to focus on the deep learning tutorial, not focusing on the neural network. So this is what we are going to talk about this. We are not going to move any further. I think there are many sessions in this year in the speech about the neural network. You can learn from there. Okay, that's some basics of the neural network. Let's see how do we do it in the Merlin system. In the Merlin system, we need to prepare some configurations for both duration and the acoustic model. After that, we can train the duration model because we need the duration information to align the source and to align the input and the output features. So here is how the configure file looks like. In the configure file, you can define where is the path of the Merlin source code, and where is your working directory, and where is the list of files for training, and the list of files for validation. You can also define, are you going to remove silence during your training? You can also define the features, the feature dimension. I think Philippe already talked about this. How many dimensions? Yeah, like that. You also have the freedom to change the architectures. You can change how many layers you want to have. For example, here, the example is a 6-layer feed-forward network, use tangent hidden activation. You can also check, modify the batch size you want to choose and the number of epochs you are going to do. You can turn on all the process and run through the whole training. You can also do this by step. I will skip this. After we have all the configuration and the duration model, we can train the acoustic model given this data. After model training, we can do some testing. For the testing, we can prepare the text information because it's testing, so the input data do not have the duration information. We need to do duration prediction first and then do the acoustic feature prediction. Here is a video to show how to train the acoustic model. Here you can change the architecture. For example, here we use 4 layers. You can also define, are you going to use RNN or feed-forward? You can define the model name. The batch size for the batch size here for RNN is the number of sentences. You can define the training of epoch. This is related to, so we can talk about how do we prepare data for the neural network input. This part is related to Felipe's talk about how to prepare the output features. After that, we can train the acoustic model to learn the mapping from input to the output features. You can see the arrow at each epoch. This is the generation after you get the model trained. So this is after the full generation is done. You can see the files you have. So after you have the data, you have many choices to design your model. Merlin also provides several different architectures. One way is if you already have the aligned input and output data, you can do it very straightforward using, for example, feed-forward network or the recurrent network. You can use the tools Merlin directly. If you do not have the aligned input and output features, you can do some sequence-to-sequence training. Currently, we don't have a recipe for the sequence-to-sequence training, but you can start from the straightforward way and to change the code yourself. But I think the current limitation is how do you choose your backend. For example, if you choose Cyano, you need to implement the sequence-to-sequence based on Cyano. Do you have any questions so far? Okay. So here is what we have already talked about. So in the regression part, our input is the linguistic feature, output some acoustic parameters. But this acoustic parameter is not the speech waveform. We need to do another step to generate the waveform based on the acoustic features.